Hello and welcome to Pseudocode. I hope you guys are doing well and I wish you a very happy Christmas and New Year wishes coming ahead. I know there has been a break in the system design videos because I was working on some great videos and some content, and also I was enjoying the holidays a little bit, but now we are back to it. And today there is a very special topic that I want to talk about, and it is one of my favorite topics, which is fault versus failures. In this video, we are going to talk about obviously what are faults and failures, what is the difference, what are the similarities, what are the different types of faults and failures, and moving towards building fault tolerant and fail safe systems. I hope you're as excited as I am, so let's get started. Let's go back to few years, like 90s, when we didn't have services like Zomato or Swiggy or Uber Eats to deliver food at the doorstep. And whenever we used to have birthdays, we used to go to bakeries to place the order to collect a birthday cake in the evening. So, in the same scenario, what used to happen? You used to go to a bakery, place an order that I want certain type of cake, and the bakery person would tell you, yes, you can come and collect your cake in the evening, and you come home happily waiting for your cake to be ready. Now, what happens if in that bakery the oven breaks? I know my drawing skills are so great. Okay, what happens if the oven in that bakery breaks on that day? When you go in the evening to collect your cake, sadly, you get an answer no, that we don't have your cake because our oven broke. Now, what happened here? Why am I talking about bakery? Think about it. The oven broke. Whose fault was it? No one's. It was system's fault. The oven broke. That was a fault. And as a result, the bakery person could not serve you as a customer. That is the failure. So you can understand that fault is something which is sort of beyond our control. And in result of that fault, a failure occurs where the customer cannot be served. So fault is sort of a cause of failure. Now, what could have been done here in order to avoid this problem? Let's think what could have been done to avoid failure. Even if the oven broke, what could the bakery owner would have done so that the customer doesn't walk home empty-handed and the birthday party still goes on? The bakery owner can give an alternative choice that sorry, we couldn't make the cake that you ordered, but here are some other cakes. Please do select one of them. Even though the customer wouldn't be 100% satisfied, but there would be some amount of satisfaction with which the customer would walk away to home. Similarly, what would have been done to avoid the fault altogether? They can have multiple ovens. So if the one oven fails or breaks, you can use another oven. But obviously, that is going to be costly. And if oven functions properly, say 95% of the time, and only in 5% of the cases a second oven is needed, then there is a huge cost to solve that 5% case. So the performance of the whole system or the failure handling in the whole system can be managed in multiple ways. One of them is tolerating a fault. A fault happened, but since there was another oven, the fault is tolerated by that another oven and it didn't affect the system as a whole. If the fault cannot be tolerated, at least the system can be fail safe, where the bakery person has alternatives to cakes, where he or she can still serve the customer. So even though the fault is occurring in a system, but still the bakery owner is able to uh, fail in a safer manner or in a graceful manner. The customer doesn't go home 100% dissatisfied. Now let's understand faults and failures in context of systems. The bad news is if you're going to build systems, systems are going to fail. What our job here is to identify those faults and failures, or yet better yet, anticipate those faults and failures and design systems in a way so that we can tolerate faults and fail in a safe manner or have fail safe systems. I know that's a lot of jargon. So first understand what are the example of faults in context of systems or distributed systems. Network faults. Your network's time out, or your machine crashes, or there is a hardware issue. The memory is a lot of memory is consumed. The system is running out of memory. The system is running on very high CPU because of compute intensive processes. And also human errors like software bugs. All these are examples of faults. In context of distributed systems, there are different categories of faults, which I want to discuss in another dedicated video. But overall, in distributed systems, these are the examples of faults that can be explored and understood. Because of these faults, what happens is the system as a whole can get impacted. For example, if you have one machine to serve all the traffic for your application, and that machine crashes, the application code crashes. So all of your customers are going to get impacted because of that fault. And as a failure, you lose a good amount of business. And that's not what we want. Similarly, if one of the components of the system fails and it impacts one business flow or one workflow, remember the workflow that we discussed in performance metrics? So, if due to the fault in one of the components, one workflow gets impacted, it is a huge cost to business. So, what can we do in order to get rid of all these issues? We can understand different types of faults. We can devise mechanisms to tolerate those faults. And then, even if those faults occur and we tolerate those faults, there are ways to make the systems fail safe. Let's understand how. Let's say you have your application code deployed on an instance, and currently it is serving 4K request. Now this machine runs out of memory, or the instance crashes, or the CPU utilization is high. In that case, what would happen? This instance won't be able to serve all 4K requests. Maybe it would be able to serve only say 50% of the request, or if this instance goes completely down, it won't be able to serve any request. So this is the fault, the hardware fault or the resource fault that have happened in the system. And in result to that, the failure is that the customer or the user who is using your app is not able to access anything. So because of this fault, that failure has occurred. This is one example of that fault. What could be more examples of the fault? If the hardware is fine, the memory CPU utilization is fine, but there is a bug in the system which is causing the request to fail. That is the example of a human error or a software bug. Another example of a fault that is occurring is that the network through which this application server is connected to the outer world, that network times out. The amount of data that is being sent over that network is huge, or some other issue occurred in the hardware lines of the network, and the network times out or it fails. That is another kind of fault. Now, how can we tolerate this fault? If there is a hardware fault, what we can do is, we can, in order to deal with hardware faults, what we can do is we can have replication. You can have multiple instances of app server, so even if one instance goes down, other instances are able to serve the request. In this way, what we are doing is we are making the system fault tolerant. Even though one system goes down, we have replicated systems which are able to serve the request and there is no failure. Now, what happens if there is a bug in the code? So, if there is a bug in the code, it won't matter if you have 3 instances or n instances, it will be there in all of the machines. And again, it is going to cause failure or a bad customer experience or bad user experience and result in failure by giving, for example, say unexpected response, or the system will enter in an error state because of that bug. What can we do for that? In order to handle with software bugs, that's why we have testing. We have developers write unit test cases, so developers have to test their code thoroughly, and then there is a QA team that tests the code thoroughly. But even after you write hundreds and hundreds of test cases, there could be some reasons which can lead the system to behave in an erratic manner. In that case, what happens is we try to handle those failures on the customer end. Say this is your backend code, there is some issue. Because of this issue, the front end app or the front end mobile app or the desktop app should not crash. It should just show a friendly message in the UI saying something has gone wrong, we are trying to get back as soon as possible, sorry for the inconvenience, etc. But instead, if that failure is not handled on the UI device and the UI app crashes or the UI app starts behaving erratically, that is again bad user experience. So we try to contain fault, we try to tolerate fault, but we also try to make the system fail safe and handle failures in a graceful manner. The same issues that can happen in an app instance can happen in a cache instance or DB instance or any other component of the system as well, which consist of some code running on some machine. In that case also, replication is one of the way to tolerate faults. So the same thing applies for databases also. If you have one DB serving all the requests, But if you want to be fault tolerant, that if at all your DB goes down, in that case you have a replica DB. And in some cases, when there are multiple nodes of DB, there are failover mechanisms as well. So when one DB goes down, the another DB becomes a primary database and it starts handling all the reads and writes. So that is another way of being fault tolerant in a system. Fault tolerance in itself is a bigger topic, and fault tolerance in distributed systems is again a very interesting topic. Do let me know in comments if you want me to make a video on details of fault tolerance in distributed systems. Now, just to give you a brief overview about the type of faults, like we discussed different types of faults in terms of if they're hardware or software or human errors or non-human errors. There are factors beyond our control. There are factors also, like there can be earthquake in data center. So there are other natural factors also which can come into play when the systems stop working. Other than that, faults are also categorized into two categories called as transient faults and permanent faults. So, transient faults in a system are faults which occur for a very brief period of time. They do not have a larger impact on the system, and they are usually hard to detect also. Moving on to the example of failures, we saw what are the different types and examples of faults in a system, but at the same time, what are the different types of failures in a system. So the request start getting 500, or the server, the whole system enters in an erratic state. One of the workflows starts responding or giving wrong data or wrong response to the user, or out of so many components of your system, one component completely stops responding. All these are examples of failures. If you think about airplanes, there are four engines in an airplane. That is fault tolerance. If one engine fails, there are still three more in the backup. And even if there are four engines, but in an unfortunate event, there has to be an emergency landing, or the plane has to be landed on water, there are safety jackets, there are emergency exits. So having multiple engines is the example of fault tolerance, and having safety jackets is an example of a fail safe mechanism, that even though the system is failing, the landing is not happening as expected, it is happening in an unexpected manner, or people have to be evacuated because there has been a fault that couldn't be tolerated. It is happening in a way so that failure can be handled in a safer manner, the lives of the people could still be saved, and hence there are safety jackets and emergency exits and the whole evacuation protocol in the place. Using the same mindset, we have to build systems. We have to anticipate the failures, we have the faults, we have to think about what could go wrong in system where, try to fix it as much as we can, and then in unfortunate events, in the events when the factors are beyond human control, we should devise mechanisms to fail in a safer manner, to fail gracefully, so that we don't lose business and the trust of customers. So that was a brief overview about fault and failures in a system, and what do we mean by building fault tolerant and fail safe systems. Fault tolerance in distributed systems is a big topic in itself, and actually, there are very interesting algorithms that are implemented in order to sustain faults. Do let me know if you want to make me a video on the same. I would love to do that. Other than that, I would like you to think about other real world systems, like airplanes, like we took examples of airplanes or bakery. Think about other real world systems where there are fault tolerant mechanisms and fail safe mechanisms, and let me know the same in comments. There are some readings in the description along with some more resources for you to refer. Don't forget to check them out. Till then, take care. See you in the next video.